I'm going to show you 3 different methods to answer this log question. We're looking to rearrange this equation into the given form of a quadratic. The first method is going to be trying to get a single logarithm on the left and a single logarithm on the right. The way we can do that is we can first of all rearrange this left hand side. We can bring the 2 up, so we can make it log base 2 of x squared. On the right, we want just a single logarithm, but that 3 is standing in our way. So we want to turn that 3 into a logarithm somehow. So this term is just going to stay the same. But the 3, we're going to write it as 3 times a logarithm. We're going to write it as 3 times log base 2 of 2. Log base 2 of 2 is 1, so we've not changed anything here. In fact, log base k of k is 1. So nothing has been changed. Now, though, that 3 can be brought up as a power, just like the 2 was on the left-hand side. So if I write that out, we now get log base 2 of 2 to the power of 3. But 2 to the power of 3, as we all know, is 8, so I'm going to put 8. Now, it's still not a single logarithm, so we can use our timesing law to say that we're going to times the middles of the logarithms when we add the logarithms together. So 8 times kx minus 1, like this. The left-hand side staying the same. Now it's a logarithm on the left, it's a logarithm on the right, so we can say goodbye to them both. And we get x squared is equal to 8 times kx minus 1. I can expand that here and say 8kx minus 8. Now there's only one step left, rearranging it all to the same side to get the given answer. So we get this as required. But that's not the only method. So another method we could do is we could take both sides of this equation and we could do 2 to the power of the left-hand side, and we could do 2 to the power of the right-hand side. It's not 2 to the power of 3 plus 2 to the power of the log, but rather it's the whole thing, 2 to the power of the whole of the left-hand side, 2 to the power of the whole of the right-hand side. We can't do much yet without still simplifying these logs, so I'm still going to use the same rule as before and bring up that 2 to make it x squared. On the right-hand side, you need to be familiar with your laws of powers to say that if you add 2 powers, it's the same as timesing it like this. So 2 to that power plus 3 is 2 to that power times 2 to 3. But now 2 to the power of a log cancels out. So we can say x squared is kx minus 1 times by 8, which we can then expand and then simplify all onto one side just as before. And luckily we get the same answer. But I did promise you 3 ways, so here's a third way to do it. What we're going to do in this method is we're going to get all the logs on one side and we're going to leave the numbers on the other. So I'm going to subtract this log base 2 of kx minus 1 onto the left-hand side, like this. And I'm going to leave the 3 where it is. Now, it's not a single logarithm on the left-hand side, so what I'm going to need to do is bring up that 2 again for the umpteenth time, and then minus the other log. And you should know that if we're subtracting 2 logarithms, it's the same as dividing what's inside them. So this will be log base 2 of x squared divided by kx minus 1. Now we have to use the idea of a logarithm, which says that log base a of b equals c is exactly the same thing as the base a to the power of c is equal to b. So it's just a rearrangement, but we can then use this to get rid of that log base 2. So 2 to the power of 3 is equal to this fraction. Once we've done that, we can then times it by that denominator, 2 to the power of 3 is still 8, so I'm going to write 8 times kx minus 1 is equal to x squared, which then tells us that if we subtract the 8kx onto the other side and add the 8 onto the other side, we get the same answer again. Which method did you prefer? Have a go at these two.